Last chapter, matrices. So we start from the beginning, the basics about matrices. So here in the first section, we'll introduce matrices, see how to perform basic operations, addition, subtraction, scalar multiplication, multiplication, and all these basics. So what do we call a matrix? Remember what is the matrix? So an M, yes, an M times N, M times N, M by N. Matrix is a rectangular array of real numbers, is a table containing what we call M rows. So this is a row, 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 row. So M rows from 1 to M. So 1, 2, 3 until N, and N columns. So this is a column. So it's a table or array of the real numbers containing M rows and N columns. Okay, all these numbers A11, A12, A1N, AM1 are called elements of the matrices. So this is an element, this is an element, this is an element. Okay, and the element is characterized by this indices. يعطيونا its position in the matrix. So I indicate the row index and J the column index. Okay, and M by N or M times N, this is called the order of the matrix. The order of the matrix. It's easy. Let's see an example. So for example, here, what is the order of this matrix A? What is the order of A? Who knows? The order. قلنا how many rows? How many rows do we have?
3.
3. By how many columns?
2.
2.
3 times over here. This is times 2. This is column 1. This is column 2. This is row 1, row 2, row 3. Okay, so the order of A is 3 by 2. What about the elements? What is the elements A12?
13.
The element A12 is 13. This means it is in the first row and the second column. So this is the element A12. Okay. What about the matrix B? What is the order of B?
2, 3.
We have
2
1,
columns.
2 rows,
No.
and 1, 2, 3 columns. وتبقى كده 2 by 3. ما نحسبها نقولوا 6. لا. The order is product of 2. يبقى كده 2 times 3 means 2 rows, 3 columns. Okay. What about B12?
Minus 17.
First
B12
row,
is this
second
element.
column.
Minus 70. This is the element. So this is the address of the element. Okay? Gives the index of the row and the index of the column. Special cases, a matrix with a single row. What does it mean, a single row?
1 row.
1 row. For example, 1 minus 3, 7, 15. Here we have a single row. What is the order of A in this case?
1 times 4.
One single row, yani M is 1, a single row. It's called a row matrix. So a row matrix is a matrix with a single row. What about a matrix with a single column? Single column, 3, 0, minus 1. This is a matrix with a single column. It's called a column matrix. It's M
3 times 1.
M times 1. Okay. So here it's 1 times n. 1 by n. Okay? For a row matrix. When we have the same number of rows and columns, n rows, n column, n rows, n columns. And what happens when m equals n? How do we call this matrix? This is very important matrix. How do we call it?
Square.
Square matrix. So square matrix means that m equal n, same number of rows and columns. And in this case, no need to write the order n by n. Since it's the same, it's enough to say it is of order n, because n gives you at the same time the number of rows and the number of columns, since it is a square matrix. So here we need only n. These elements, these special elements, A11, A22, A33, where the index of the row equals the index of the column. So all these elements are called the diagonal elements. عناصر القطرية على القطر. So the diagonal, the main diagonal of the matrix is a column matrix containing AII with index of the row equals index of the column. This is called diagonal elements. So these are some examples. This is a column matrix, 3 rows, 1 column. This is a row matrix, 1 row, 4 columns. This is a square matrix of order 2, 2 rows, 2 columns. So easy. Determine the order of the matrix. What is the order of A?
2 times 2.
Okay, so this is a square matrix.
Or 2.
So it is order n equal 2. What is the order of this matrix B?
3 by 2.
3 by 2. What is the order of C?
1 by 4.
How do we call C?
Row matrix.
It's a row matrix. What is the order of D?
4 by 1.
4 by 1. It's a column matrix. So this is easy for the moment. Zero matrix. Zero matrix is a matrix with elements. All elements are zeros. All elements are zeros. It's called the zero matrix. And we have to write this to indicate the order of the zero matrix used. So 0, 2, 3 means that it's a matrix of order 2 by 3 where all elements are 0. This is a matrix 0 of order 2. It's a square matrix of order 2 where all elements are 0. Okay, so this is how we denote zero matrices. We indicate the order. Okay, to know how many elements we have. we have triangular matrices. There are two types of triangular matrices. Upper triangular matrix. What does it mean, upper triangular matrix? So قلنا, how do we call this? Elements. شو سميناها؟ هذا A11, A22, A33.
Diagonal.
The diagonal. This is the diagonal. A matrix is an upper triangular matrix when all elements below the diagonal are 0. It's called an upper triangular matrix. It looks like a triangle, an upper triangle. Okay, so all the elements below the diagonal, are 0. And in the same idea, we can define the upper. What can we define else? An upper triangular matrix, and we can have also upper or lower. كيف راح يكون شكلها lower triangular matrix? So we'll have 5, 0, 2, for example,
It's
-1, 0,
everything
3.
above.
Here, this is the diagonal, but here above the diagonal are 0. So this is called the lower triangular matrix. Okay, so this is an example of a lower triangular matrix. And we have what we call a diagonal matrix. What do we expect? What's a diagonal matrix?
The upper and a bit lower, it's all 0.
Okay. Only diagonal elements can be non-zero. All other elements are zeros, except the diagonal elements. Here we can have 0, no problem, but all the elements which are not on the diagonal are 0. In this case, it's called the diagonal matrix. So these are special types of matrices. Now, equality of matrices. So if we have two matrices A and B, when can we say that A equals B? When we have two equal matrices. Two matrices are equal if they satisfy some conditions. The first condition is that they must have the same order. If they don't have the same order, they cannot be equal. But this is not sufficient. Two matrices are equal if they have the same order and if each elements at the same position are equal. If for every I and every j, the element A in the position ij equals the element in B in the position ij. شو معناها لازم A11 equals B11 لازم A12 equals B12 لازم A13 equal B13 and so on حتى للأخير كله. So let's see an example. Here we have two matrices. Let's say this is A, this is B. What is the order of A?
2.
So this is of order 2. What is the order of B?
2.
2.
It's also
2.
order 2. So they have the same order. إذا شو لازم؟ لازم هذا this element A minus 1 لازم equals 2. ولازم this element 3 equals this element 3. ولازم this element 2 equals this element 2. ولازم this element 3b equals the corresponding element in B6. So these are the conditions for which the two matrices are equal. Then هذه easy equations تعطيني A equals 3. This is satisfied. 2 equal 2, this is satisfied. And this is satisfied when B equals 2. So if A equal 3 and B equal 2, these two matrices are equal. Okay? So this is the equality of matrices. Same question here. What is the order of this matrix?
2 times 3.
2 by 3. What is the order of this matrix?
2 times 3.
So the order matches here. So they are equal if P equals
4.
4. 0 equals 0. This is okay. 6 equals 6. This is fine. Q plus 4 equals negative 2.
Minus Q is minus
Q
6.
must be minus 6. R over 3 must be equal to 3.
R is equal to 9.
R is 9 and 1 equals 1. So this is the condition for which these two matrices are equal. إذا أعطاك هنا 2 بدل 1 قل له they are different. They cannot be equal. Because at least one of the elements in A and B doesn't match. Okay? لازم all elements equal. Okay? This is important to notice. All elements must be equal to get equal matrices. Okay, now we go to addition and subtraction. So شفنا في الفاكتورز الاديشن والسبتراكشن. Vector are special cases of matrices. So it's easy. So we use the same definition. We have only rules, condition to be able to perform the addition. The two matrices must be also of same order to add. To add, the two matrices must be the same order. In this case, we add the corresponding elements. We add A and B at position ij. We subtract the corresponding element ij in A and in B. So it's easy. So let's see A plus B. So A is a matrix of order 3 by 2. B also. So same order. So A plus B exists. We can perform here this operation. What do we get? So this is 3 times 2. This is 3 by 2. So the result will be also a matrix with the same order. So here we'll have 3 rows and 2 columns. Okay? So we can book the places for the matrix. This is important in programming. So you have to لازم تحجز لهم مكان. Okay? So here the first element, how do we compute the first element?
A11 plus B11.
Exactly. So using the values here, we'll have 20 plus 25. The element 1 in A plus the element 1 in B. Here we'll have 13 plus 10, 15 plus 12, 15 plus 17, 12 plus 8, 10 plus 8. Now this is the sum matrix. It's a matrix, so this is easy, straightforward. This is how to make the sum. Same thing for the difference. A minus B, it will be 20 minus 25, 13. 13 minus 10. Be careful to not make an error in the computation. But it's easy. So we'll have the matrix minus 5, 3, 3, negative 2, 4, 2. This is the matrix A minus B. It's a matrix of the same order than A and B, 3 by 2. Perform the indicated matrix operations if possible. Why is saying if possible? It's not always possible to add matrices. Of course not. It's not always possible. So A plus B, is it possible? Yes, this is order 2, this is order 2, same order. So we can add, we get negative 3, negative 3, negative 3, negative 2. A minus B, okay. We get minus 4 minus 1, 0 minus minus 3, 1 minus minus 4, minus 2 minus 0. So we get the matrix negative 5, 3, 5, negative 2. What about C plus D? Can we add C plus D? C plus D.
I think yes. Even though they're not the same, but their C's row number matches with D's column number. I mean, C's column number matches with D's row number.
Okay. Well, with that math is a logic subject. So we say we can only add if they are the same. And you are saying, okay, they are not the same, but there is no but. Are they the same or they are not?
They're not the same.
If they are not the same, so no exception. So here the matrix is of order 1 by 3, and this matrix is of order 3 by 1. Do they have the same order?
No.
No. So this does not exist. Undefined. Cannot add. Not the same order, no addition. What about A minus C? Okay, Abdurrahman, here also 2 by 2, this is 3 by 1, so not possible. No addition. We cannot add. So for matrices, we cannot always perform the addition, only in special cases. Next, as we saw in vectors, here also we have a scalar multiplication. We can multiply a matrix by scalar C. C times A. C is a scalar number. Okay? And this case, we'll get this matrix of same order than A. So the new matrix, C times A, will have the same order than the original matrix. And as we did in vectors, multiplying a matrix by scalar means that you multiply all the elements of this matrix by C. CA11, CA12, CA13, CA1n, CAMN. Okay? So it's easy, just multiply all the elements by C. So here 5A. So what will be the matrix 5A? So A is 2 by 3, so we'll have 2 rows, 3 columns for the result. What are the elements?
5.
So we multiply all elements by 5. 5, 0, 15,
minus 10,
negative 10,
25, negative 5.
This is 5A. What about XB? So it will be matrix also, 2 row, 3 column, and we'll multiply all the elements by X. So X, 0, 3X, 2X, X, 0. This is the matrix XB. What about XB minus C? So we have XB, 2 by 3. We have C, 2 by 3. So, okay. So 2 rows, 3 columns. So we'll have X minus X, 2X minus T, 0 minus Y, X minus 5, 3X minus z, and 0 minus minus 1. And we see whether we can simplify. X minus x is 0, 2x minus t minus y, x minus 5, 3x minus z, and 1. So this is, we can also combine addition, subtraction, multiplication by scalar, and we have to follow the order of operation. The order of operation. When we have multiplication and addition, start by multiplication. We have the same order of operation as we saw it from the first lecture in Math2. The same order. Exponent, then multiplication, then addition. Okay? Parentheses have priority. Okay? The same order. Okay, here also easy. 3a, what about 3a? Okay, let's do it one time. 3a will be 3, negative 6, 0, 15, 9, minus 3, minus b, wait a bit. So b can wait a moment, minus 2c, so 2x, negative 2, 4, 10, 2y, and negative 2. Then we make this subtraction first. 3 minus 1, 2, 0 minus 0, 0, 9 minus 3, 6, minus 6 minus 2, minus 8, 15 minus 1, 14, minus 3 minus 0, minus 3. ننزل هذه to continue. قلنا 4, قلنا 10, قلنا 2y, قلنا minus 2. And we subtract 2 minus 2x, 0 minus 4, 6 minus 2y, minus 8 plus 2, so minus 6, 14 minus 10, so 4, minus 3 plus 2, it's easy, just go step by step, multiply first by scalar, and then add or subtract. Any question about addition, subtraction? No question? Okay, we move. So we have the same properties. Commutative, addition, the order is not important. Associative, when we have 3 matrices, we can add the first and the second and then add the third, or add second, third, and then add the first, so the order is not important. Minus a is the opposite, so if you multiply all elements of a by minus 1, you add it to a, you get the 0 matrix. This is a scalar, you can distribute, so these are elementary, nothing new. This is a new. This is a new operation. ما شفناها قبل اللي هي transposition. The transpose. شفتوها قبل ولا لا؟ The transpose. مين شافها؟ Have any idea about transpose? It's easy. So what the transpose matrix denoted by AT, A transpose, A transpose. So A transpose is obtained from the matrix A by transforming the rows of A are the columns of A transpose. So a row of A become a column in A transpose. So transform, we write the rows as column. And of course, as a consequence, the column of A become the rows of A transpose. So if A is of order m by n, the transpose will be of order n by m. It's very easy. Let's see an example. Find the transpose. So this is a matrix 2 by 3. So the transpose will be a matrix 3 by 2. So we'll have 3 rows, 2 columns. So this is the row 1 in A. The row 1 in A will be the column 1 in A transpose. So this is the row 1. كانت row في transpose تصير column 1 0 3. The row 2, this is the row 2 in A, become the column 2 in the transpose. -2, 5, -1. This is the transpose, which means that this element in A can A1, 3. The new elements will be
A3, 1.
A transpose 3, 1. Okay, then they play opposite roles. The row become a column and the column become a row. This is what we call the transpose matrix. Okay, it's a new operation. So properties. So the transpose for the addition we can distribute. So the transpose of A plus B is the transpose of A plus the transpose of B. If we multiply A by scalar and we make the transpose, it's the same that we make the transpose and then we multiply by the same scalar, K. So transpose has no effect on scalars. ما عندهاش scalar في transpose يبقى هو نفسه. So this is why we didn't introduce it for scalar, for real numbers. Transpose ترجعك للأوريجينال ماتريكس. هذه واضحة. So here A transpose إذا تحب ترجع تعمل transpose تحب تعمل AT transpose. So it's 3 2 ترجع 2 3 وتصير هذه the first row تصير the first column 1 -2. The second row تصير the second column 0 5. The third row تصير the third column 3 -1. So what do we remark here if we compare it to the original matrix A? What do you see?
Yes.
Guess what?
A transpose just puts it back in the same order.
Sit back انك نطيت ورجعت على قدمك. Transpose, one of the application is to define what we call symmetric matrices. Then شفنا symmetry for graphs. On a graph, for example, a parabola like this. قلنا عندنا symmetry with respect to y, to the y-axis, for example. This is symmetry شفناها في الgraphs في geometry. For matrices also we have what we call symmetric matrices. But it must be first a square matrix. We talk about symmetric matrices only for square matrices. If it's not squared, it's not symmetric. It's obvious because a matrix is symmetric if the transpose equals the original matrix. Okay, so if A transpose is A, we say that it is a symmetric matrix. We'll see why is it called like this, symmetric. So what do you think? This matrix, is it symmetric?
None of them have the same order, so they are not symmetric.
So this is of order 2 by 3. It's not squared, not square matrix. So obviously not symmetric. Another A. What about B? B is a square matrix. It's okay. Is it symmetric? So Abdurrahman say yes. Do you agree?
I don't think so. If we change the order,
let's compute B transpose to be. So what will be B transpose? So this is the first row. Qulna will be the first column. The second row will be the second column. And we compare. Do we have B equal B transpose?
No.
No. So if they are different, since they are different, so B also is not symmetric. What about C? So it's a square matrix, okay. What is C transpose? So 3 rows, 3 columns. What is C transpose? So this is the first row, become the first column. The second row is the second column. The third row is the third column. And we compare C and C transpose. Are they equal?
Yes.
Yes, they are. So C is symmetric. If you want to know it directly from the elements, can we? Yes, we can. So هذه diagonal. We have a symmetry with respect to the diagonal. So here the element A2, 3 is the same as the element A3, 2. The element A1, 3 is the same as the element A3, 1. Okay? So switching I and J doesn't change the element. This is what we call a symmetric matrix. When Ij equals Iji. Okay? This is a symmetric matrix. And we can show it using the transpose. Okay, last part in this section, the multiplication. So this needs special care. تركناها للأخير ليش؟ لأنه special وحكينا على الترانسبوز والسيمتريك ولسه ما حكينا على المالتيبليكيشن. حكينا على المالتيبليكيشن by scalar. So be careful. We already said that for vector, no multiplication of vector. Cannot multiply factors. Can we multiply matrices? Yes, what under some conditions. We cannot multiply matrices. Okay, always. So the first condition, very important, the condition is that we can only multiply matrices when the order if A is n by n and the order of B is n by p. What do you remark here? What is the condition if we want to say it in other words?
Rows and columns are the
لازم
same.
the number of columns of A match with the number of rows of B. Columns of A match the number of rows of B. This is the condition to multiply matrices, the only condition, necessary and sufficient. Okay, it's necessary to have the number of columns of A equals the number of rows of B to multiply, and it's sufficient to have it. Okay, so this is the condition. Now, when we are able to multiply, how do we multiply? We multiply row by column. We multiply a row of A by a column of B. How it comes? Multiply A, B here. So first we have check whether the product exists or not. A is a matrix of order 2 by 3. B is a matrix of order 3 by 3. So do we have matching here?
Yes.
Yes, they match. So yes, we can multiply. And when we multiply, we obtain a new matrix. What is the order of the result?
2 times 3.
The result will have the number of rows of A and the number of columns of B. This is the result, A times B, the order of the result. So how do you multiply now? You say we use calculator. Okay, if you want, you can use it. Or if we want to make brain training, we want our brain make some activity, some sports. So the result will be a matrix with 2 rows, 3 columns. What are the elements of this matrix? Let's say this is C11, C12, C13, C21, C22, C23. How to obtain the first element C11? The first element is obtained using the first row of A by the first column of B. How? By multiplying the first element by the first element. 2 times minus 2 plus. then عندنا multiplication فيها addition. تشبه شوية لل scalar product, but it's not scalar product. Okay, it's different. Then we add 0 times minus 3. Then we add 3 times 0. So here it is -4. And we do this for all the elements of, for all rows and all columns of A and B. So here this is done. This is done. This is done. We go to the next element, C12. How to compute C12? We use 1, so the first row of A to the second row column of B. And we multiply element by element. 2 times 0 plus 0 times -1 plus 3 times 2. So it's 6. And so on. So this is the strategy to multiply 2 matrices. And you continue till you do all to, you fill all the matrix. C13. Now to compute C13, you use the first row and the third column. And you multiply 2 times 1, 0 times 4, 3 times 5. So it's 17. Then we finish the first row. We go to the second row. Now C21. How to compute C21? C2, so second row ونرجع للفirst column. مقابلين. So we'll have 1, -2, -1, -3, -2 times 0. And we compute, we get 1, and so on. So this is the idea. هل هي واضحة? This is how to perform multiplication of matrices. ريان، اوكي خليني اقرا سؤالك. لو سويت نفس طريقة الحل بالعكس، يعني بديت ب 3 times 3 2 times 3 هلا عادي. خلاص عرفت جوابك. ممتاز، لأنه سؤالك صعب شوي. خلينا نشوفوا الحين حسبنا AB قلنا AB no problem we can multiply. بعد طلبنا في BA. What about BA? What do you think?
Not possible.
AB possible BA not possible? ممكن. So B 3 times 3, A 2 times 3. Do we have matching?
No.
No.
No matching. So not possible. Okay. So أريد نحكيه على commutative AB equal BA وكانت تبان obvious في الأول. It's not so obvious. It's not always the case. Here, for example, for multiplication of matrices, it's clear that it's not commutative. So AB mostly different from BA. It can be equal, but generally it's different. So in matrices, in multiplication of matrices, the order is important. قال لك A B تبقى A الأولى وال B الثانية. إذا غيرتهم زيرو خطأ. أصلا ممكن ما no result أو different results. So be careful. The order is very important. The multiplication of matrices is not commutative. What about CD? Can we multiply?
Not possible.
هنشوف C. What is the order of C?
3.
1 times 2.
1 by 2. What is the order of D?
2 times 1.
2 by 1. So can we multiply? Does it match? Here, 2
Yes,
and
yes.
2. So yes, they match. What will be the result?
1 times 1.
Result 1 times 1. What does it mean? Starting a matrix with one row,
character.
one column. It's one element. It's a scalar, let's say. Okay. So here we can multiply and we'll obtain a matrix. So C here. So CD will be 2, -1. أسوي الحركة هذه حتى يسهل علي. حتى ما أتلخبط. لكن ممكن تكتبهم على نفس الخط. في ناس كثير يكتبوهم على نفس الخط. نسوي كده حتى أعرف 1 1. So عندي only one element الحمد لله to compute. How to compute it? Using the first row and the first column. So we'll have 2 times -1 plus -1 times 3. So it's -5. So the result is a matrix with one element, -5. What about DC? Can we multiply D by C? So what's the order of D?
2
times
1.
1.
2 by 1. What's the order of C?
1 by
1
2.
times 2.
1 by 2. Does it match?
Yes, sir.
Yes, they match. Okay. What will be the result? What is the order of DC?
2 by 2.
So the order of DC will be 2 by 2. So شفتوا CD is one element, DC is a matrix, 2 rows, 2 columns. خلينا نحسبوا DC -1 3, C 2 -1, and this is the result. So the result will be a matrix with 2 rows, 2 columns. Then هنا we'll use the first row, first column. So we multiply just -1 by 2. So here, alhamdulillah, no addition. So the element هذا first row, first column. So 1, 6, and -3. So CD and DC here both are possible, لكن totally different matrices. This is the multiplication of matrices. It's very special. Be careful when you perform it. So start with checking the orders, whether we have matching, they match. So the order of the result will be, this is the order of the result. Okay? And then you use rows times column. So row 1, column 1, row 2, column 1, row 1, column 2, and so on. And this is the calculation. So طويلة, it's واحد, but we don't have the choice. You have the choice since you are lucky, so you have the calculator. So this R, BA is not defined, no matching. CD is defined and gives 1 by 1 matrix, R1, C1. And of course, DC match also, and we'll have the 2 by 2 matrix. Okay, so try quickly to compute AB to see whether you understand or not. We are done. This is the last example. So what about AB? Who is able to compute AB without calculator? At least give me the first element. So this is 2 by 2, 2 by 2. So matching. So we'll have matrix of order 2 by 2. So what will be the element of the product? What is this element? Who knows how to compute this element?
First row of A, first column of B.
So row 1, column 1. So row 1 times column 1. So 1 times 3 plus negative 1 times 5. So this element is negative 2. What about this element, for example? Get it? Row 2, column 2. So how we compute row 2, column 2? Row 2, column 2. So 0 times 0 plus 2 times negative 1. So here also negative 2. You can compute any element you want. This element. Row 2, column 1. Row 2, column 1. Don't need this, don't need this. We need this. 0 times 3 plus 2 times 5. Gives 10. This element is 10. Okay, and so on. So you can compute AB, you can see the result. Get the result here. So this is the result. Okay, you compute BA. Here it's possible, but completely different result. So be careful. For the last time, multiplication of matrices is not commutative. The order is important. AB is A أولى B ثانية. BA start by B, then multiply by A. So it's associative, we distribute. So we are done. Here, this is an important matrix. You'll see it later. It's called the identity matrix. I don't know whether we'll see it later or not. The identity matrix, here matrix square, diagonal. شو معناها diagonal matrix؟ يعني except the diagonal or all the elements are 0. And on the diagonal we have ones only. And why is it important? Because you can check that if you multiply a matrix by the identity matrix, you get A. Whether you multiply to the left or you multiply to the right. And this, as I said, might be different. So you have to compute both. Okay? Because we have multiplication to the left and multiplication to the right. They are different. They might be different since multiplication is not commutative. Okay? So you can enjoy if you have time and try to make the multiplication. So we are done. Equal matrices, addition, subtraction, multiplication, transpose, and symmetric matrices.